I wanted to go over this constant velocity practice set too. When I checked it, some people did a really nice job with this. Others, had a lot of misunderstandings. So I'm going to talk through some of these things, and there'll be some questions as an ed puzzle. So on this page one, remember this is first of all, this whole set is about constant velocity. So we're not talking about accelerated motion. So this is asking you to sketch velocity versus time graphs corresponding to the following descriptions. So here, if we're moving slowly, again, it's got to be a constant velocity. But if we're moving slowly, we would have a horizontal line a little bit above zero on the vertical axis, or something like that, if that's in the positive direction. If we're moving slowly in a constant speed in a negative direction, we'd be below here. We wouldn't be at an angle because our velocity isn't changing. Again, this is all constant velocity. If you still think it should be, I think you're thinking of a position time graph. A position time graph would have the graph have a constant slope, but a non-zero slope. And for positive velocity, that'd be a positive slope. For negative velocity, that'd be a negative slope. Here, if we have a moving quickly in the positive direction, we would still have a horizontal line. I know that doesn't look particularly horizontal, but that would be farther above zero, and moving quickly in the negative direction, this would be farther below zero. For something not moving, whether you think of positive or negative direction, that's going to be zero velocity the whole time. Over here, this is going from 0 to 4 seconds. So I'm given a position graph, I should be able to determine the velocity graph. The way I have to do that mathematically, since these have numbers, I have to get the slope. So if you remember, slope is change in y-axis, that's change in position, or change in x-axis, that's time. So this goes from 0 to 4 meters in 4 seconds. So that would be a positive 1 meter per second, which is also the slope of this graph. For number 2, the slope changes. So in this particular region, I've got a slope of positive 2. In this region, I go up from 2 to 4, but I do that in 4 seconds. So that's a slope of plus 1/2. So I have a constant velocity of plus 2 meters per second here, and a constant velocity of plus 0.5 meters per second here. In this region, I have plus 1 meter per second. In this region, I'm going negative 4 meters in 2 seconds, so that's negative 2 meters per second. So constant plus 1 immediately changing to constant negative 2. Going to the next spot, what we end up finding here is one of these things is given, and the others are things you have to do. So in this case, we're given a position time graph. Constant positive velocity, no motion. Constant negative velocity that looks a little bit steeper. So I have a constant value here for the velocity, so constant positive velocity, zero velocity, negative constant velocity that's a little bit further below zero than this was above zero. Here I've got a constant negative velocity, then for a shorter time period, although I don't think I showed that well up here, constant positive velocity and then zero velocity. This looks a little slower than this because it's a little closer to the this axis. So negative, positive, zero. Here I'm given the position time graph. I have to figure out the velocity time graph. So I have a constant negative velocity that's got a slope not very much different than zero. So that's a slow moving thing. So it's close to zero, not moving, and much steeper negative slope. So I have a much more negative velocity. Here, zero velocity, highest positive velocity, negative velocity that's not as fast because again it's closer to zero. So these are the descriptions of that. And what's I've got here is I've got some of the motion maps. And the motion map should agree with all these three things I talked about. So here, moving at a slower positive velocity, staying at rest for a couple of seconds, a faster negative velocity. Here I start off with a fast negative velocity, slightly slower positive velocity, not moving. Slow negative, not moving, fast negative velocity. Not moving, fast positive velocity, slow negative velocity. For the last one here, I think these were kind of difficult for sure. They were somewhat challenging. And what we end up having happen here is we've got an object, we've got a description moving with a constant positive velocity, then it stops, then it returns to the initial position in 2 seconds. So it's got to be moving faster in the last region than in the first region because it's taking 2 seconds to move the same amount of distance as we did in 4 seconds. So I went up here, low slope, but positive slope, stopped, steeper negative slope. I end up at the same position as I started. Low positive value for velocity, zero velocity, more negative velocity. Arrows, short arrows to the right, stopped, large arrows to the left. This one, we were given here, this looks like it's faster to the left, then stopped, then slower to the right. So it's almost the reverse of this. So I have a very negative slope and a very negative velocity, zero velocity. Then I'm moving slowly to the right over more time. Low slope, longer amount of time. Here, I have two objects which cross each other. So object A is starting to the right and moving to the left. So it's going, down. It's going back towards zero. Object B starts to the origin, is moving to the right. It's moving a little bit faster. So I have something like those. This one's a little bit tougher. There's a couple ways you could have interpreted this. I interpreted this that B is moving for less time than A, only for 4 seconds as opposed to 5 seconds, because the dots are the same distance apart and the arrows are the same length. I assume that they were going the same speed. And since they're going the same direction, that means the same velocity. So these lines would be parallel to each other. They'd have the same slope because, again, I've got the same speed. So I essentially said that the object B wasn't moving in the first second and then is moving the same speed in the next 4 seconds. And hopefully that helps you out.